Welcome everybody. Today I will be talking about building a plant monitoring application with InfluxDB Python, Flask, and edge to cloud replication. So for those of you who don't know me, I am a developer advocate at InfluxData, and I encourage you to connect with me on LinkedIn if you want, but also to come find me in our community Slack and our forums as well. If you have any questions about anything related to time series or this presentation, I would love to talk with you about those topics there. So I just wanted to give a quick overview over what we'll be talking about today. So first I'll describe the IoT hardware setup that we use to build a plant monitoring application. Then I'll talk about the various tools that we use to build it. Next, I'll give an overview of InfluxDB and what we do. Then I'll talk about our data ingestion setup so that we can get all of the data about our plant, like temperature, pressure, soil, humidity, and other sensor data into InfluxDB. Next, I'll talk about Flux, which is a query language for InfluxDB, as well as SQL, which you can also use to query InfluxDB. Then I'll talk about how you set up edge data replication, which is a feature with InfluxDB that allows you to replicate data automatically from an open source instance to a cloud instance. So you have a way to centralize and consolidate all of your IoT data. And then I'll talk about the code base and where you can find this example so that you can give it a go for yourself. All right, so now let's talk about the IoT device. So this is what the diagram roughly of our Plant Buddy system looks like. And as you can see, we store and manipulate data here on the open source build of InfluxData. And then we downsample that data at the edge as well after collecting data from our plants. And then we consolidate that data and replicate it to InfluxDB Cloud before serving it finally to the end user with a Flask application. So in order to complete this project yourself, you'll need the following things, although in no particular order. Preferably a plant that's alive so that you can actually monitor it, although you can monitor something else if you wanted to. We recommend using a particle boron microcontroller, but you can use any compatible microcontroller. And then you need at least one IoT sensor for your plant. And last but not least, a breadboard with jumper wires and terminal strips. So this is what the breadboard schematics looks like for the setup. So we are hooking up 4 sensors to our breadboard. And this diagram hopefully helps break down what that looks like and what ports the microcontrollers and sensors are connected to, so that if you decide to do this project yourself, it'll make setting up the exact same thing a little bit easier. And we're using the following sensors: temperature and humidity, light, soil moisture, and temperature of the soil as well. So now let's talk about some of the tools that we use to build this application. The first is Flask. So Flask is a micro web framework that's written in Python, and it's going to be doing the heavy lifting for the majority of this project. And it'll help us run our local application and routing. Then we're also going to be using InfluxDB. We'll be using a few features from InfluxDB because InfluxDB at its core is a time series engine and database, but it also comes with a powerful set of APIs and client libraries, and we'll be taking advantage of those for reading and writing data. We will be using the database as our main storage for the time series data that is coming from the IoT devices that are monitoring our plants. And I also want you to be aware that there is a massive community and ecosystem around InfluxDB. So it's worth taking advantage of that as well if you are going to be creating any sort of application on top of InfluxDB. So we'll also be using, in addition to the APIs and the client libraries, we'll also be using Telegraf for data ingestion. So Telegraf, InfluxDB and Telegraf both have open source offerings, and Telegraf is fully open source, and it is a collection agent for metrics and events that is plugin driven. InfluxDB and Telegraf are both downloadable as a single binary, And the agent has over 300 plus plugin options that you can choose from. So we'll be using specifically the Telegraf execd plugin to send our data to InfluxDB for the open source build of that. And then this is our client library suite. So there's client libraries available in many popular languages, and they allow you to read and write, and in some instances also manage your instance a little bit. And we'll be using a client library to query data from InfluxDB Cloud before serving our data to the end user. So we will be using, or you can use client libraries instead of Telegraf plugins if you want, and we'll be showing a code example of how to do this as well. And then last but not least, I believe, we will be using, as far as from all the InfluxDB products, we'll be using a Flux extension for VS Code. So this allows you to execute queries, create tasks, which are just queries that are executed on a schedule, checks and notifications. And it's great specifically for writing Flux. And Flux is a query and scripting language or InfluxDB OSS. And it's sort of similar to Pandas in that like each additional function that you add further manipulates your data and transforms it in some way. So it's a pretty powerful tool, and using the VS Code extension just makes writing an application that much easier because you don't have to go back and forth between the InfluxDB UI and the place where you're presumably writing all of the rest of your code. So other tools outside of InfluxDB, we'll be using Plotly for graphing. So Plotly is free and open source as well, and it helps you build interactive publication quality graphs. It's a really great tool if you're not familiar with it already. So without further ado, let me give a quick overview of InfluxDB so you have a little bit more context for why it is that we're using InfluxDB to actually build this Python application. And before I do that, I need to take a step back and answer the question, well, what is time series? If InfluxDB is primarily a time series database and engine, what is time series? Time series is just any data that has a timestamp associated with it. And we usually think of examples like weather conditions, any stock data or prices, cluster monitoring, healthcare, logs, traces, etc. If we want to focus on healthcare, that's a great easy example to understand the two types of time series data, which include metrics, which are regular time series data, and events, which are irregular time series data. So, for example, in the healthcare space, a metric might just be your heart rate, and an event might be sort of arrhythmia. And so while your heart rate may be collected at a regular time interval, if there is the presence of an irregular type of time series, and that is a event. So where is time series seen, and where can we find it? The short answer is that it can really be found in pretty much every type of application. So we see a lot of time series coming out of the consumer and industrial IoT space when we think of things like manufacturing and industrial platforms, or fleet management, or renewable and alternative energy systems. There's a bunch of IoT and time series data coming from that. Things like predictive maintenance, but also monitoring of equipment, and also predicting supply and demand as well. Then we also see time series in software infrastructure as well. Things like Kubernetes and Docker and in general DevOps monitoring produce a ton of time series data, as well as monitoring to various developer tools or third-party endpoints or APIs. And then we see real-time time series data also being collected from the following applications: gaming applications, fintech is obviously a huge source of time series data, and network monitoring. So where does time series databases fall in the history of databases? Well, originally we started off with relational databases, then we moved toward document databases and next search databases, and finally we see this emergence of time series databases, And the reason why we see this category emerge is primarily because the databases that existed before time series databases didn't really meet the requirements for a lot of time series use cases, primarily around the fact that time series generally requires really, really high throughput and really, really high both reads and writes. And ideally, a time series database should be optimized to prioritize read and writes over other database actions like updates and deletes. Not that you can't perform those within a time series database, but that's definitely not going to be one of your main actions. And that's because generally time series is unique in that you are almost always concerned with your data as it's presented within the context of what came before and what's going to come after it, and not usually that interested in what happens during a single point of your time series data. Additionally, time series databases should have a lot of features built into them to help you work with time series data, just because time series data is notoriously hard to work with, whether that's converting timestamps, shifting time, manipulating time, working with time across different time zones. There's just a bunch of small features that should be, hopefully you don't have to write yourself, that you can use out of the box with whatever time series database you use. All right, so this is an all-up reference architecture for InfluxDB, and it's probably the clearest way to, demonstrate what InfluxDB is and Telegraf is and Flux to the developer community. So essentially the idea here is that there could be a variety of different data sources that you're gathering data from, time series data from, and you will be sending that data to InfluxDB or another time series database with either Telegraf. Again, Telegraf is the plugin driven collection agent that is database agnostic with client libraries, or also native ecosystem tools. And then once that data is in InfluxDB, you can transform the data, you can downsample that data, you can create triggers or alerts on that data. And then you can also collect data with InfluxDB itself with the query language in open source, and then push that data, whatever data you've gotten after you have transformed it in the appropriate ways, to further application workflows, to gain infrastructure insights, or even take IoT action on it. All right, so now let's talk about the data ingestion setup a little bit. So I'm not going to go into depth on how to set up the microcontroller here, only because each one is unique, and honestly, you should probably just follow the setup instructions that are unique to the one that you're using. But for the sake of understanding the code from here on out, I want you to be aware that mine is running on a port on my computer because it's plugged in directly. And this is an example of how the data comes in. And when I run the command particle serial monitor, it shows me the data stream coming in. And the sensor data is also highly varied. So I'll be skipping the details for how I decided to clean this up and the additional tagging that I used just to clean the data even further. And all of this code is available on GitHub later for your review. So if you're more curious about this cleanup portion of this, then you're welcome to check that out. So here, when you have your open source InfluxDB instance installed and running, even on localhost, you'll see a UI like this. And the first thing you're going to do is set up your bucket, and your bucket is where you're going to be writing data to. So we just set up our bucket like that. And then the next thing we're going to do is generate an API token. We'll generate an all access token here and name it as well. And we'll name it Plant Buddy, and we'll be using this in the rest of our project. And you can also similarly create read and write tokens that are scoped to specific buckets for increased security. And I generally suggest creating an all access token when you're first just playing around with InfluxDB, just to make your life easier so you don't have to worry about whether or not you accidentally scoped your token to the wrong bucket. And then you can create a new one and replace it with buckets that have, or with tokens that have additional restrictions if you see fit. Okay, so now that we know how we actually create a bucket and a token, we are actually ready to start writing data. So this is an example of using the InfluxDB v2 Python client library, which allows us to write a few lines of code to begin streaming data into InfluxDB. And the point of this code here is to use the point method to write a single point to the database. And basically, what we do here is we specify any tags that we want, which are kind of just metadata about our point. And the field is where we're going to actually create or store the meat of our time series data. So in other words, like our sensor and the sensor value. Whereas a tag would be maybe like the user, whoever plant this is, and the device that this data is coming from. And we've already assumed that we've instantiated the write API, which we did the last line by including the bucket, the organization, which is usually just the email that you use to sign up. But you can also find the org in the UI as well, like right next to where the tokens and buckets were. And then we pass in that record and we can go ahead and write that point. But we can also write data to InfluxDB with Telegraf. So Telegraf is configurable through a single toml config file, and this is what the toml config file looks like. So the entire file can be quite large, not because it's complicated, but because it's annotated with a ton of comments, which is helpful for when you are looking to edit it yourself. So I'm not going to go into depth on how to set it up. If you go to Telegraf on GitHub, all that documentation is there, as well as if you go to the InfluxDB documentation, there's a ton of documentation on how to set up Telegraf. It's a pretty easy tool to use. But for reference, here's a small part of the total config file, and it is the part that we honestly care about the most, which is the inputs plugin part of the config. And so we'll be using the execd, and the execd inputs plugin. What it does is it makes Telegraf extensible in any language. So in this case, what we're doing basically is we are using a command, Python 3, and pointing to our the location of our serial_read_telegraph.py file. So basically, we're going to be running that file to output data in line protocol, which is the ingest format for InfluxDB. And so basically that file helps take our data from our sensors, clean it up, and change it to line protocol so that it can be ready to consume. And I said line protocol, but in fact, the data format is actually going to be JSON. As we can see further down, the data format is JSON. So there's a variety of different formats that you can choose when you are working with Telegraf. And then we specify within that JSON what the string fields are, what the tags are, etc. And then once we've written our data to InfluxDB and we've queried it, this is an example of what the resulting table would look like after a query in InfluxDB. So we can see that all of our data is being written to a measurement, and a measurement is just the second kind of like largest hierarchy underneath a bucket. So all like data would be kept under a single measurement. We have various fields, light and soil, moisture and temperature, etc., and then the corresponding value for each of those fields as well. And then finally, we have our timestamp for each of those points. And so the fact that data is split out like this is like a little alarming for people that come from a relational background, because they usually expect to see like the field name as a column name and then the value directly underneath it. The reason why in OSS engineers decided to have this layout was to handle the case where there are a ton of null values, where you have one sensor that's maybe reporting at a nanosecond precision and then like another sensor that's reporting hourly. If you queried for both fields simultaneously, you'd obviously have billions, I believe, of null values for that one field that's reporting at a really higher ingest rate. But you can also use Flux to pivot your data into the way that you would expect. So don't be too alarmed by this. Which brings me on to the point, Flux versus SQL. So Flux is the query language and scripting language for InfluxDB OSS, but in InfluxDB Cloud, we're moving towards providing users with the ability to query in SQL, primarily because that's what most people are familiar with, and they don't have the bandwidth to learn Flux, or alternatively, they'd rather use SQL to just query their data, pull it out, and then use the tools that they're already familiar with, like pandas and Python, to do any further data processing or data cleansing with that. That being said, for this project, we do use Flux in the open source version, and this is what it looks like. It's kind of JavaScript-esque in its syntax. It uses these pipe forward operators to indicate that you're going to be taking data, and then each pipe forward operator implies that you're going to be taking the output of the previous line and piping it forward into this next line, and getting an output from that. And each line will essentially be transforming your data further. So in like a pandas world, it's like essentially like tacking on, any method like, dot mean for your data frame. And let's just look at what a basic Flux query is so that we don't get overwhelmed, because you don't really need to worry about it that much in order to execute this project. So this is what our basic Flux query looks like. Basically, we're saying we're going to query data from a particular bucket, and that bucket is a destination bucket where we wrote our data to. We'll specify a range for which we want to query our data from, and then we'll use the filter function to say we want to filter for specific data, specifically the data that is from a unique measurement with a particular device ID and a field. And we're also including variables in that Flux call so that we can make that whole call dynamic. And we can change them. So again, I want to talk a little bit about the change in the future of InfluxDB, because you don't have to query Influx in InfluxDB Cloud anymore. So InfluxDB Cloud, we recently launched InfluxDB Cloud powered by IOX. IOX is just the new storage engine for InfluxDB Cloud, and it brings SQL support with it. It will also allow storage in Parquet file format. It also supports unlimited cardinality. So if you choose to use the edge to cloud replication version of this project, where you consolidate your edge data in the cloud, instead of consolidating it to another open source version, then you can actually try out querying with SQL instead. And it's built on the entire Apache ecosystem. So it's built on Apache Flight, Apache Data Fusion, Arrow, and Arrow Flight SQL, and Parquet. And because of this, it offers a ton of interoperability. So now you'll be able to actually use Apache Superset, Tableau, Power BI, and Grafana as well for any of kind of sort of the BI and analytics that you want to do with InfluxDB. So that's kind of why we moving away from Flux and moving towards this new solution, just to allow developers to use the tools that they're already familiar with. But that being said, let's talk about edge to data replication. What is it? Okay, so essentially, to summarize, edge to data replication allows you to set up a replication stream that allows you to automatically replicate data from the edge to a cloud instance. And the advantages of it are that it reduces the bandwidth cost associated with sending high fidelity data to the cloud. And it has network resiliency for the case of any intermittent failures or connectivity issues to the cloud. And so to summarize, it's just this hybrid solution provides the flexibility to move mundane tasks such as downsampling to the edge and consolidate your data in the cloud so that you can perform more interesting analysis there, or have more clean data there. So tangibly, what this feature is that it consists of 2 new API endpoints, /remotes and /replications, with 2 new CLI commands that follow, the remote command and the replication command. And so basically what you got to do is you got to set up a replication stream and specify from what remote instance you're going to be doing that. And each replicated bucket also gets a disk-backed queue for buffering and data safety in case of any disruptions. So how do you set it up? Well, you can see the setup instructions here, which can be found on the GitHub README. But basically, yeah, you can spin up the Docker Compose file, and then that will launch an InfluxDB OSS Edge and the Plant Buddy server app. And then you can connect the Edge instance to the cloud instance with the CLI and apply a template. A template is just a pre-configured set of resources within InfluxDB. So it's just a fast way to load like dashboards and configurations and stuff like that. So you do that, and then you want to check which port your device is connected to, and then export the port as an environment variable and run your Telegraf config so you can actually write data to your OSS instances. And then to set up the edge to cloud replication, these are the two commands you'll need. First, you'll need to create a remote connection with the influx remote create command, and we'll name it Plant Buddy Cloud, and we'll specify the remote URL, so basically where we want to be sending all of our data to. And then once that remote connection has been established, then we'll create a replication stream. And these basically describe the rules of what we want to be replicating and how between a local bucket and a cloud bucket. So essentially all we do is specify like the local bucket ID that we are writing data from or replicating data from, and the destination bucket. All right, so now let's talk about data requests and visualizations. So we'll be querying data from Influx, and in this step, we're calling for the previous Flux Query and infilling the variables with our selections, including our bucket, our sensor, and our device. And we'll return the result that allows us to graph our incoming data. And we'll use the query underscore data underscore frame method to actually pull data back out into a data frame format, a pandas data frame format. And there's other styles that you can choose from. I just love pandas. I'm a huge fan of it. So if I have an option to work with pandas, I will be. And alternatively, though, you can also query data from InfluxDB Cloud with SQL. So in this case, we're using Apache Aeroflight SQL, and we are executing the query with SQL instead, and then we are converting the output to a pandas data frame with PyArrow. And an advantage of using this and using PyArrow and these tools is just that you can query a lot more efficiently and query a larger volumes. So that's another exciting feature of using the Apache ecosystem in InfluxDB Cloud powered by IOX. So now that we actually have our data, we're actually ready to start graphing our data. So this is the end result of querying for the data points and actually being able to graph them. And as you can see here, this is an example of the hard-coded graphs, but we also, in the GitHub example, in the GitHub repo, we have an example for selectable graphs as well. And this is what our application looks like. So we can see our dashboard here that's delivered to the user with an overall light, soil and room temperature, and room and humidity, and soil moisture. So this is kind of what all of our plant data looks like. So without further ado, I want to take a moment to talk about some further resources. So you're welcome to try this application yourself. You can scan the QR code and that'll send you directly to the repo, or you can follow the links below. There's two versions. There's the one that's with OSS, and then there's the one that also includes IOX as well, InfluxDB Cloud powered by IOX. So if you want to try querying with SQL and take advantage of that free cloud tier, you're welcome to do so as well, whatever suits you. But either way, no matter what you do, I hope you come and join us in the InfluxDB community Slack workspace and ask any questions about this application, about time series. If you have cool plants, come talk to me about that. I'd just love for you to join the conversation there. And then if you're more interested specifically in InfluxDB Cloud powered by IOX and learning about how it's built and why it's built upon the Apache ecosystem and why we're making these changes, I encourage you to join the InfluxDB_IOX channel and ask away. And then if you want to get started yourself, you can use the following QR codes to not only go to Influx community organization, which is a collection of repos from the community and from other developer advocates around all sorts of projects you can do with InfluxDB, but also get started using InfluxDB itself. And then here are some further resources. Get started with at influxdata.com/cloud, but also please go to the forums as well if you have questions there, or you want to find existing answers to similar questions you might have. We have Slack, we have GitHub, we have a book that is help developers write applications, IoT applications on top of InfluxDB OSS. We have our amazing docs, a lot of blogs, and even InfluxDB University, which is a place where you can get and take courses on all things InfluxDB and earn digital badges as well, and that's all free. So yeah, if anyone has any questions, I'm here for a couple more minutes and I would love to answer them. Otherwise, thank you so much for attending this presentation.